Good morning again. Jonathan and I will trade off a couple times talking through these slides. And for an outline, what we want to do is first just talk a little bit about why engineering at Taylor University. A lot of our sister institutions don't have an engineering program, and so it's somewhat unique within our sphere of institutions. We'll give a brief history of our engineering programs, or how it came about, and then status of our engineering programs. And then finally have some conclusions. So why engineering at Taylor? First of all, let me just say a little bit about the background or what Taylor University is. It's a Christian liberal arts university, which if we kind of take that apart a little bit, as a Christian institution, we are intentional about being Christ-centered, kind of the focus of our instruction and our practice. When we think about liberal, we think of the idea of the freedom to study subjects for their own intrinsic merit, their beauty, their excellence, not necessarily just purely because there's vocational value, but truly because there's excellence and beauty in them, and ultimately we believe them to be reflective of God who created those things that we study. And then in the liberal arts, we think of that as a broad set of subjects that help form the whole person. So classically, it'd be like the trivium and the quadrivium. We have a different set of general education requirements. But here we study engineering with that same liberal arts training that all of the other graduates have. There are, I think, 54 credit hours of general education, and our graduates are required to take those same general education requirements as every other student from other majors. So it makes for a challenging program, but we're committed to that. We believe that the appropriateness of a particular program's presence within a liberal arts university is most importantly judged by the degree to which the program is taught liberally. I mean, to be honest, there are sister institutions who don't believe that engineering belongs in a place like Taylor, in a liberal arts institution, because they say this is a vocational, it's a professional degree. And that's not what liberal arts institutions are about. But we believe it's more about how liberally you teach the subject matter. And so although, yes, we're preparing our graduates to serve within the engineering community, we approach engineering in a liberal sense. The idea that it's much broader than just you need to learn this so that you can get a job. There's a deeper reason for it. And our heritage and our identity as a Christian liberal arts institution really gives us deep roots in that sense. You may have heard the expression, the phrase, "The earth is the Lord's and everything in it." It's a verse from the book of Psalms in the Bible, and for me it just came to my mind when I was putting this together, thinking of how this, I think, captures the culture here at Taylor. Our worldview is that we live in a world that God created us. He created everything around us. And so as creator, God is both a master artist and a master engineer. And as His creation, we think it's good, and we believe that God in His Word teaches us to image Him by doing similar work, to be creative, whether it be an artist or whether it be an engineer. And so the vocation maybe is not the most important identifier, but rather, are we reflecting who we believe our Creator is, and thereby give Him glory? So we think of this environment here at Taylor, where students have 4 years of study, as being this awesome privilege for them to devote 4 years of their lives to studying ultimately what we believe to be the handiwork of God, whether it's how they've been created, the fact that our minds can actually understand these things, and we can actually come up with theories that explain what we observe in nature, and when we can build on that to then produce useful and helpful things in society, or whether it's just looking around us, looking at the stars, looking at within our bodies, looking within math, whatever, to see really the handiwork of God. And so that happens whether it's a Bible class, whether it's physical education, math, science, or engineering. And we really do believe that, and we speak to that even within the engineering classes. We believe that ultimately teaching engineering in this context results in graduates who are well prepared and desirous to serve in the communities or the companies, wherever the constituents that they go to serve. And they're able to meet the needs of those communities. And this, I guess I'll say, just in looking over the program or the student outcomes from ABET, a number of those actually are connected in some ways almost more naturally with the core education that we have here. To be able to work in a multidisciplinary team, to communicate effectively, to be aware of the societal, political, the context in which we work, a spirit of continuous learning. These are things that are deep in the culture of Taylor University. And so it's been natural to actually make sure that our program helps students attain those, because that's something that we're doing throughout the university to begin with. Ultimately, our vision, and this ties with the mission statement of the university, our vision statement for our Taylor engineering graduates, is that they would glorify God by doing the good works that God has prepared for them to do. So there's this strong idea of stewardship. And you find, throughout both the faculty, staff, and the students, that we kind of feel like we're entrusted. It's a tough degree, and not everyone is able to study engineering, but those that are may be doing so because they feel that they've had a trust placed on them. Kind of to drive this a little further, wanted to just mention about the POEs.
Do you mean POs, Program Educational Objectives?
I mean Program Educational Objectives, yes. Sorry.
No, that's all right.
The danger of acronyms.
Oh, it has happened to me many times. Don't like
PEOs.
POs, yeah.
The POs. Program Object. Yes. Thank you. Here I have it at least.
Yeah, that's right.
So here are our educational objectives. We want to serve others dependent. We want our graduates to serve others dependably, to practice technical competence, to exercise creativity, and to pursue growth. And the interesting thing is that through the ABET process, and one of the things I was hopeful to communicate is that we're indebted to the ABET process. It's been tough to do this here because we're a smaller institution, and it's just been a lot of work. And yet we can attest to the fact that these current program educational objectives have come straight from the ABET process. 2 years ago, we had to address this through an interim report, and in that process, we developed these, which were a revised set of PEOs. But interestingly, those came from something deeper than just simply trying to meet ABET accreditation. Sometime before, we had developed this idea of the characteristics, the qualities that we wanted our engineering graduates to graduate with. And we had this idea of mind, heart, and hands. So this technical competence, creative problem solving, dependable and opportunistic service. The idea in dependable is when the world changes around you, that your boss can still depend on you when you come in and they say, guess what, the department has just been flipped upside down and you have a new role. Opportunistic is that you see something falling through the cracks that is not your direct responsibility, but when you see that it might belong to someone else, you grab it. You look for those opportunities. But all of that actually comes from our deep Christian faith, because we see all of those as being a way of honoring God. And so when we created these, we had another set that actually we created first, and that these flowed out of. And they're what we call our whole person life objectives. So we have a first undergirding one, which is, love God with all of yourself. And then we have serve others through love. Practice spiritual competence, living by God's law, which is very parallel to technical competence. The idea of, as engineers, we don't usurp the natural laws. You don't just MacGyver something. You actually diligently learn the theories and the first principles. Walking by the Spirit, which yields eternal fruit. And here we have this mystery, creativity. We believe strongly that engineering, in the end, is a creative endeavor. And there's a spark of creativity that's a mystery. Any of us who've solved a problem, there are times where did that idea come from? And so there is a mystery to it, and that is reflected also on the spiritual person side. And finally, pursuing spiritual growth. So I share this almost partly just as a message back to ABET that even though ABET is not a religious or a faith-based organization, yet it has helped us to actually clarify our underlying motives, our underlying vision for the program from which these more, I guess, professional objectives have flown from. And so we're embedded to the process.
This is great. How did you arrive at this four? Who participated in coming up with these four?
It went through the same process as with PEOs. That we drafted them, but then we ran them through our constituents, both the students and alumni who also serve as employers as well, to validate that these are the types of personal characteristics that they want to see from our graduates, and not just the professional characteristics that they want to see.
Yeah, so Jonathan probably had the heaviest hand in creating these, but we brought them to our students, we brought them to the judges who are external constituents, practicing engineers. At the poster session, we shared them with them, and then with our faculty as well.
Have you documented that you guys sought input and?
Yeah, we went through that process. Jointly with all 9 of these. Yes.
Sorry for interrupting.
No, that's fine. Okay. Another characteristic of our engineering curriculum is that we talk about having 2 prongs. One is a strong foundation in learning and understanding. So kind of this broad engineering foundation. From our curriculum, we don't have electrical or mechanical, but we have more this multidisciplinary engineering, physics, and then computer engineering. And it's built on a rich liberal arts core with then selected, if you will, deep or high learning excursions. So we say, we're going to take the students through some deep learning or scale this mountain, which at first they think they can't scale. And they scale it, they succeed on it, and then we teach the broader context such that the goal is that they then can take that learning and apply it over here in an area where they haven't had explicit training to go that deep, but they say, I understand because I have this broad view. I understand that the same basic principles are in play over here as they were in here. And we have seen students go on to grad school and in industry where they've practiced things that they never studied explicitly within their coursework. There's a focus on first principles and then taught in a multidisciplinary context, so we don't have silos between electrical or mechanical and so forth. And the goal ultimately in this classical kind of underlying foundational learning is, our goal is that the students would learn how to learn, and they'd love to learn. That's what we're really after, and they would apply their learning to otherwise unfamiliar areas that we don't cover within the curriculum. And ultimately that they have a reason to learn. We want that fuels the lifelong learning.
And as a side, just the student who showed up yesterday out of the blue, he was telling us that that's exactly what was going on. He was in an engineering context where he was having to do some computer engineering skills, even though he's an engineering physics student, and that he was able to live in that world very comfortably.
The second prong then is just a strong practice of doing and creating. So we focus on equipping students with practical skills, whether it be software tools or hands-on tools in the laboratory. And as we've noted before, and you've seen from the poster session documentation, we have 100% student participation during each of the 4 years in the program. For freshman to senior, they are working on projects. So I think I'll pass this on to...